All right, guys, here's a little bit of an overview of metabolism. Now, this is straight out of page 835. I wrote down all the information, but if you want some nice pictures, page 835 is where it's at. This is our overview. One is digestion. Two, we form acetyl-CoA. We'll talk about that. The citric acid cycle, that gets a lot of love. And then electron transport and oxidative phosphorylation. Those are some big words, but it's actually not too bad. So here we have one, digestion. There's three stages or three ways we start digestion. If we have triglycerols or fats, we break them down into fatty acid, which I'm going to write down as Fa, and glycerol. So we just break it apart. You guys remember running this reaction? I made you do this on tests. Carbohydrates, those get broken down into monosaccharides. That actually occurs with your saliva as soon as you get it in your mouth. There's a reason why, like when you see bread, your mouth waters because you're priming yourself to eat that loaf of bread. I love bread. Proteins, they get broken down into amino acids. We just did proteins, we leave those amide bonds, and we start getting individual amino acids. The second part, the formation of acetyl-CoA, that goes through, happens in a couple different ways. So first of all, you have your fatty acid, right? If we oxidize the fatty acid, we go straight to acetyl-CoA. It's great. There's no other steps. Glycolysis, this has to do with carbohydrates. Here we have a lot of different things going on. We can generate ATP right off the bat. This is why like sugar is something that'll get you hyper because you generate that ATP right away. Some of it goes to pyruvate, and that pyruvate then gets converted to acetyl-CoA. Then amino acid catabolism, which is our breakdown from bigger molecules to smaller molecules. Some of it goes to pyruvate, some of it goes directly to acetyl-CoA, and then some of it gets dumped into the citric acid cycle. It depends on which amino acid. That one, we're going to talk more like a general sense. All right. So citric acid cycle, we generate a bunch of ATP. Okay. And what we do is we get these reduced coenzymes, and they get dumped in what's called electron transport, and we get more ATP. ATP is going to be a big to-do for us. All right. So digestion. Here we go. Um, it's the catabolism of food. It's taking big particles of food and breaking them down into small molecules. It's catalyzed in the stomach, the saliva, and the small intestines. This happens like in a lot of different areas. Large pieces into smaller molecules. This is an example. This first one right here, that's a carbohydrate. This next one, this is a protein. There's our amino acid. And here's our triacylglycerol, or a fat molecule gets broken down into glycerol and the fatty acid. All right. So here, stage 2 through 4, we just did digestion, it was very quick. So here, what we get is monosaccharides and amino acids and fatty acids are degraded into acetyl-CoA, or acetyl groups. Those acetyl groups, which are 2 carbon units, so it's a chunk of a molecule that's 2 carbons long. They get bonded to coenzyme A, hence acetyl-CoA. Citric acid cycle, this is based in the mitochondria. Acetyl groups get oxidized to CO2. That's why we breathe out CO2, and energy becomes stored in specific bonds. Electron transport, we produce ATP. This is our primary energy carrier, and oxygen combines with H ions to form water. So you sort of have a combustion reaction happening inside of you. You're taking carbon-containing compounds, reacting them with oxygen, you get CO2 and water. So here, monosaccharides, amino acids, and fatty acids degraded to acetyl groups, which is CH3CO. So CH3CO, and then we have this bond to sulfur and your coenzyme A. All right. So no matter what, monosaccharides, amino acids, and fatty acids, they're all degraded, and eventually they all form this product right here, which we call acetyl-CoA. Don't worry about that sulfur; it's in there, but we don't have to deal with it too much. The citric acid cycle, it's why we exhale CO2. This will be broken down into a huge amount of detail. And then the electron transport, O2 combines with H plus and electrons to make H2O. Biomolecules are converted to CO2 and H2O, just like when you're burning wood. And this is how energy is produced and stored.